Welcome to Astronomy Daily. I'm Anna. We've got an incredible show lined up for you today, packed with fascinating stories from across the cosmos. We'll journey from the mind-bending concepts of our expanding universe to the mysterious black holes competing for dominance in a distant galaxy. Plus, we'll check in on SpaceX's latest preparations for their next Starship launch and celebrate a remarkable decade of NASA's observations of our solar system's giant planets. Stay with me as we explore these amazing developments in space and astronomy. So let's get started. Have you ever wondered what the universe is expanding into? It's a question that might seem simple at first, but actually touches on some of the most profound mysteries in modern cosmology. Let me try to break this down in a way that might help us wrap our minds around it. Think about baking a loaf of bread. As it bakes, the dough expands into the space of the baking pan. But here's where our everyday experience fails us. Unlike that bread dough, the universe isn't expanding into anything. It's simply expanding into itself. The universe began about 13.8 billion years ago with the Big Bang. But contrary to what the name suggests, it wasn't a giant explosion. Instead, it was a moment when every point in the universe began expanding outward simultaneously. Scientists can actually track this expansion by observing how other galaxies are moving away from our own Milky Way. What's even more fascinating is that this expansion is actually speeding up. This acceleration puzzles astrophysicists because it seems to defy gravity itself. Something mysterious is pushing everything apart with increasing force, and we call this invisible force dark energy. It's mind-boggling to think that this dark energy makes up about 68% of all the energy in the universe, while the matter we can see, stars, planets, and galaxies, accounts for only about 5%. When scientists try to understand what might lie beyond our expanding universe, they run into some remarkable challenges. Some theories suggest there could be multiple universes out there, which might help explain some of the puzzling aspects of quantum mechanics and gravity that currently don't quite fit together in our models of physics. But for now, we can say with certainty that the universe continues its relentless expansion, with galaxies drifting further apart as time goes on, all driven by this mysterious dark energy that we're still working to understand. It's a humbling reminder of just how much we still have to learn about our cosmic home. For those who dream of exploring the outer reaches of our solar system, NASA's Hubble Space Telescope has been providing us with an incredible window into the dynamic worlds of our giant neighbors. This year marks an impressive milestone, 10 years of the OPAL Program, which stands for Outer Planet Atmosphere's Legacy. Back in 1989, the Voyager missions gave us our first close-up views of Neptune, completing their grand tour of our solar system's giant planets. But that was just the beginning. Since then, Hubble has been taking up the torch, conducting annual observations of Jupiter, Saturn, Uranus, and Neptune that rival the detail of those historic Voyager flybys. What makes OPAL particularly special is its consistency and comprehensive approach. Unlike ground-based telescopes, Hubble's position above Earth's atmosphere allows it to capture incredibly sharp, stable images of these distant worlds. It can observe everything from ultraviolet to near-infrared wavelengths, giving us a complete picture of how these massive planets' atmospheres behave. Each of these giant worlds is a cosmic weather laboratory. They don't have solid surfaces. Instead, they're wrapped in deep atmospheres with stunning displays of cloud bands and long-lived storms. Their years are much longer than Earth's, which means their seasons stretch on for years at a time. This makes Hubble's long-term monitoring absolutely crucial for understanding their atmospheric dynamics. The scientific impact of this decade-long survey has been remarkable, with over 60 research papers published using OPAL data. The program has become a cornerstone of planetary research, working hand-in-hand with other observatories, including the James Webb Space Telescope, which can peer even deeper into these planets' atmospheres using its infrared vision. As we celebrate this 10-year milestone, OPAL continues to build an ever-growing database of planetary observations, allowing scientists to track long-term changes in these fascinating worlds as they orbit our sun. It's a testament to Hubble's enduring legacy and its ongoing contributions to our understanding of our cosmic backyard. Let's move on to a SpaceX update. SpaceX is gearing up for another milestone in their Starship program, with preparations underway for their 7th test flight of the revolutionary mega rocket. Just yesterday, the company conducted a crucial static fire test of the Super Heavy first stage booster at their Starbase facility in South Texas. All 33 Raptor engines roared to life briefly, marking a significant step toward the upcoming launch, which could happen as soon as January 11th. This follows the impressive progress we've seen in recent test flights. The last two missions were particularly successful, with both the Super Heavy booster and Starship spacecraft reaching space and surviving their return journey. On the fifth flight, they even managed to catch the Super Heavy booster using the launch tower's mechanical arms, a key capability for SpaceX's vision of rapid rocket reusability. Meanwhile, Rocket Lab has been pushing boundaries in a different direction, successfully completing a suborbital hypersonic test mission for the Department of Defense. This flight was part of the Multi-Service Advanced Capability Hypersonics Testbed Initiative, designed to advance hypersonic flight testing capabilities for the United States. The mission featured an advanced test platform specifically engineered to accommodate larger payloads for hypersonic technology assessment. What's particularly noteworthy is that Rocket Lab managed every aspect of the project, from initial design through to the integration of experimental hypersonic instrumentation, all on an accelerated timeline. As George Rumford, director of the Test Resource Management Center, pointed out, these commercial launch services are proving invaluable for the nation's hypersonic development program. They're enabling more frequent and cost-effective testing of components, which is crucial for advancing this cutting-edge technology. This mission adds to Rocket Lab's impressive track record since 2017, during which they've deployed over 200 payloads for various commercial and government customers from their launch sites in both the United States and New Zealand. These recent achievements from both SpaceX and Rocket Lab demonstrate just how quickly commercial spaceflight capabilities continue to evolve and mature. Next, let's take a journey about 40 million light-years away to the constellation Lupus, where the Hubble Space Telescope has captured a stunning image of the spiral galaxy NGC 5643. This isn't your ordinary galaxy. It's what astronomers call a grand design spiral, with two beautifully defined spiral arms adorned with brilliant blue stars, intricate dust clouds, and vibrant pink regions where new stars are being born. But the real drama in NGC 5643 is happening in wavelengths our eyes can't see. At its heart lies an active galactic nucleus, powered by a supermassive black hole. As this cosmic giant devours surrounding gas, it creates a superheated disk that blazes across the electromagnetic spectrum, particularly bright in X-rays. Here's where things get really interesting. Using the European Space Agency's XMM Newton telescope, scientists discovered something unexpected on the galaxy's outskirts, an X-ray source even brighter than the central supermassive black hole. Known as NGC 5643X1, this mysterious object appears to be a much smaller black hole, only about 30 times the mass of our Sun. This stellar mass black hole is locked in an orbital dance with a companion star, stealing gas from its partner to create its own superheated disk. Despite being thousands of times less massive than its supermassive cousin at the galaxy's center, this smaller black hole actually outshines it, demonstrating that in the cosmos, size isn't everything. It's a cosmic David and Goliath story, where the smaller contestant is putting on quite a show. This discovery challenges our understanding of black hole behavior and reminds us that the universe still has plenty of surprises in store. The fact that a relatively small black hole can outshine the massive engine at a galaxy center shows us just how complex and dynamic these cosmic phenomena can be. Finally, today. This week's launch schedule shows just how busy space exploration has become, with multiple missions lined up from various launch providers around the world. SpaceX is leading the charge with an ambitious schedule of 3 Falcon 9 launches planned within just 28 hours. The first of these launches will carry a batch of Starlink satellites from Vandenberg Space Force Base in California. Following that, SpaceX has planned 2 back-to-back launches from Florida's Space Coast on Friday. The first will deploy 2 O3B mPOWER satellites for SES, designed to provide high-throughput internet services. Just 3 hours later, they'll launch a GPS satellite for the U.S. Space Force, further enhancing our global positioning capabilities. Meanwhile, in Japan, Space One is making another attempt at reaching orbit with their Kairos rocket. This comes after their first launch attempt in March encountered difficulties. The mission will carry several small satellites, including an interesting payload featuring the first Buddha statue intended for orbit. Looking back at recent achievements, we've seen some remarkable numbers. November alone saw 29 orbital launches, averaging almost one per day. Even more impressive, we've already surpassed last year's record of 221 orbital launches, with 229 successful missions so far this year. SpaceX hit several milestones recently, including their 350th flight using a flight-proven booster and their 100th successful landing on their drone ship. Just read the instructions. They've also completed their first direct-to-cell constellation shell, marking another step forward in their satellite communications network. This increasing pace of launches demonstrates how space access is becoming more routine and commercially viable, with multiple companies and countries contributing to our growing space presence. It's a clear sign that we're entering a new era of space exploration and utilization. And that brings us to the end of today's episode of Astronomy Daily, where we've explored everything from the mind-bending concept of universal expansion to the latest developments in space launch technology. I'm Anna, and it's been my pleasure to guide you through these fascinating stories from the cosmos. If you'd like to stay up to date with all things space and astronomy, I invite you to visit our website at astronomydaily.io. There, you can sign up for our free daily newsletter and access our constantly updating newsfeed of space and astronomy news. You'll also find our complete archive of past episodes ready for your listening pleasure. Want to join our community of space enthusiasts? You can find us across all major social media platforms. Just search for Astro Daily Pod on Facebook, X, YouTube, Tumblr, and TikTok to follow along with our latest updates and join the conversation. Thank you for spending time with us today exploring the wonders of space. Until tomorrow, keep looking up and stay curious about our cosmic neighborhood.